and a warm welcome to everyone. I hope I can live up to that wonderful introduction. Thank you. Let me share my screen. Okay. I hope you can share my screen. Yes, thank you.
Yeah.
Okay, so well, good afternoon, everyone. My name is Kers. I'm the Solution Consulting Director for AspenTech in Asia Pacific and Japan. And I've been working in the industry now for more than 20 years, and I was born and raised in the Netherlands, and I moved to Singapore quite a number of years ago. So thank you very much for joining my talk. I'm going to talk about the self-optimizing plant. A new era of autonomy powered by industrial AI. And I think now with the COVID-19 pandemic that's going on and all the supply, demand supply disruptions, the industry faces very strong headwinds. And so I think new levels of operational automation, which was talked about earlier, will be required, not only to position companies for success, but simply just to survive. So the plant of the future, I think, will be more productive, even more productive, squeeze the last droplet out of the plant and more agile. So performance will be raised to new heights and new levels above those that we thought were possible, maximizing the performance across multiple dimensions, whether that's safety, sustainability, availability, and most importantly, provide ways to sustain this value. So what are exactly key characteristics of a self-optimizing plant? So to achieve these goals, plants, I think, will become more self-adapting. So in real time, they can adjust and steer the plant to its appropriate optimum. Self-sustaining, plants will be able to foresee failures way ahead of time. And self-learning, plants will be able to mine the existing data in the systems and predict the future more accurately. And so they will be able to become, they'll be able to predict future conditions and, if necessary, eventually automating the entire execution securely in a closed loop feedback. And you may wonder why now, why not 10 years ago? I think we're at a crossroad. Apart from the current pandemic that has highlighted the necessity for us to change and develop, our competitiveness. I also think that currently all these technologies are becoming real. Real-time access to data, rich domain knowledge capture and automation, and a combination of first principles modeling together with AI. It is the reason why I think this vision of a self-optimizing plant is becoming real. Okay, and this is our disclaimer. So a lot of what I'm showing today is vision, and so this is for the purpose of discussion. That's the reason for the disclaimer up front. Now, first, for the people who may not know AspenTech, AspenTech is a world leader in asset optimization, and we call it the capital-intensive industries in the energy sector, and even beyond in the chemicals. And we have about 2,300 customers worldwide. We work with many of the leaders in our industries who help to drive our innovation forward. We have a tremendous industry expertise. We have experienced people in our organization, in our customer base. And just to give you an example, we have over 100 PhDs in our domain of people. And we train about 6,000 users annually. And then proven value. Our customers generate, on average, $50 billion US per year in value. So this is improving margins and making their operations safer and more sustainable. And we have built up a foundation of innovation over the last almost 40 years, and we heavily invest as a company into innovation. We hold over 120 patents, and we have a very exciting strategy of industrial AI that I'm going to talk about today. And we really believe this will generate new levels of value for all the industries we serve. And AspenTech, our capability builds on a solid foundation of industrial AI, where data access enables customers insight into their operations, plus close to 40 years, 4 decades of domain expertise means that we at AspenTech, we think we understand some of your challenges in the energy and petrochemical industry. Okay. So at AspenTech, we've been building our portfolio, our product portfolio, so to speak, with this mission and this journey in mind. And the goal is to provide a comprehensive, holistic approach to the entire asset lifecycle or asset optimization. When you look back at the history of AspenTech, 40 years ago, we were busy optimizing individual units, maybe a furnace, maybe a crude distillation tower, or a separation tower. And gradually we have invested, innovated, and acquired, and built our portfolio around, the design, pushing the boundaries on what's possible, how to then operate these plants against their limits of performance, and how to drive uptime through actionable insights. And this basically summarizes how AspenTech has built up their portfolio over the years. Our vision of a holistic approach to asset optimization is realized through this diagram. It's what we refer to as our digital reference architecture. It covers design, operations, and maintenance across the entire enterprise. So when we first look at design on the left, performance engineering is what we call it. It consists of two elements: the plant digital twin, optimizing the OpEx by mirroring the asset in a model, and then optimizing CapEx and time to market by using these performance engineering models. And all the way to the right, you see our asset performance management also consists of 2 elements: to assess reliability and minimize risk, and prescriptive maintenance. So how do you avoid unplanned downtime? And then in the middle is the heart of the supply chain in most manufacturing, which is the production optimization, where we've made strong progress closing the gap between planning, scheduling, and actual operations through a number of unique and innovative solutions, which we call dynamic optimization for refining and olefins producers alike. And we've also closed the gap by streamlining the flow of data, order entry to production scheduling for specialty chemical producers or customers. So leveraging our plant digital twin within our performance engineering solutions, we are able to further enhance the production optimization by improving the integration between the simulation models and, for example, planning. Can we make the planning models more accurate by using our rigorous digital twins and model some of the key unit operations in a non-linear fashion rather than the old and proven LP way of linearizing all these equations? Because some of these reactor conversion units don't behave linearly, they behave non-linearly. So there's an opportunity there. And then additionally, using our asset performance management, we can actually expose the actual condition of the underlying plant or health of the process by making prescriptive maintenance information available to planning. So ahead of time, predicting when something is going to fail, uh, maybe 30, maybe 60, maybe 90 days ahead of time. So maintenance can be planned. Planning can re-optimize their plant and minimize margin leakage. And this basically explains AspenTech's portfolio in, when you look at design, operate, and maintain. And our portfolio focuses on these digital reference architecture elements. Now, outside of the fence, second dimension is the value chain optimization, connecting outside of the fence across the supply chain from forecasting of the supply and demand to distribution and fulfillment. And our value chain optimization solution allows you to plan more holistically, maybe a multitude of manufacturing sites inside of an enterprise network. And so we are extending our capabilities to share actionable insights and automate the execution across business function, optimizing the design, operations, and maintenance across the life of the asset at a higher level, and thus enabling the smart enterprise. Okay. So having said that, where AspenTech, where we stand, what our portfolio covers. So what are some of the digitalization technology trends and opportunities? So we're in the midst currently. One example is we have an explosion of connected devices. I mean, I'm here talking to you. I have my phone connected. I have a second laptop as a backup connected. Um, People are dialing into this event all over Asia, and we are reaching 30 billion devices in the next 5 years, which allows us to create a network of connected devices that can monitor, that can collect information, exchange, analyze. Uh, Process and manufacturing industries are generating more than 200 times more data than they were 30 years ago. And the question is, are we using all that data? And then the availability of new, 4.0, so-called industry 4.0 technologies that are becoming very readily available. Machine learning, artificial intelligence, cloud computing, augmented reality, virtual reality, drones, and even robots. And all these new technologies are, I think, required to take advantage of this vast amount of data and all this connectivity that is emerging around the globe. And so this can radically augment the way we work. It can evolve your workforce, automate tasks, enhance analysis, and creatively solve problems. But there are also significant disruptors to the business. Think back in the 1990s, in the early internet. We were just laying the foundations, but since then, with all these new business models and all these companies that sprouted up in the 90s, how many of these companies have disappeared? And if you look now at the Fortune 500, it looks very different from how it looked 10 years ago or even 5 years ago. So I think we need to stay on top of them. So let's have a look at let's talk about the new generation of industrial applications that blend first principles with AI capability. So, I'm not an expert in all this. I'm a chemical engineer, but nowadays it seems like the internet is a candy store for data scientists. TensorFlow freely available, Python. My son is downloading all kinds of new machine learning algorithms that he experiments with. It's a true candy store for data scientists right now. And there's really a plethora, and I'm sure you can come up with a few more or new and exciting technologies out there. So there's really no barrier to entry. Like in the past, these things are openly available, freely downloadable. And with such a technology at your disposal, almost anyone can set up a company. I mean, there are about 900 AI companies, uh, according to one of the leading consultants, uh, measured last year, and there may be 400 IoT platform companies, probably more. But when you look at this approach, right, our vision is that you really would need an army, a battalion of data scientists to do this for you and to combine all these solutions. And we feel it's not really scalable. If, for example, what you really need is analytic solutions, not really a collection of technologies that you have to assemble yourself. We believe this technology should be more and more embedded into the software that you already use. And it should be wrapped with workflows and ease of use so that it can easily be implemented by your domain experts, such as the engineers. Okay, so the ML code that's at the heart of this real world production system, but it only represents 5% of the overall solution. You're still going to need an army of data scientists to put it all together for you. It needs to be embedded, into the software that we use, rather than just picking up Python from the web and trying to solve these problems yourself. So our vision really is to embed IA solutions, AI into our solutions, so you really don't have to do it. We are taking the data throughout every system you have from across your processes, assets, and then we apply a combination of intelligence. This could be a form of AI and ML capabilities, or any other advanced analytics, such as multivariate analysis, to provide a rich understanding of the industrial data. But we combine it with the first principles engineering that we are familiar with, whether that's physics or chemistry, at the heart of your highly complex assets, and leveraging our 40 years of domain expertise. And when we combine this, we can really deliver actionable insights that could power, measurable KPI business outcomes, proactive decision-making, guidance, plant-wide workflow automation, really to transform how work is done and to elevate operational efficiencies that can be gained. And this is what we call industrial AI. We are democratizing not only the access, but the actual application of AI in an industrial context. So it's fit for purpose, it's domain specific, it's AI enabled with sustainable business value. So think of the physics and the chemistry as the infrastructure for safe and efficient operations, and then AI capabilities as the enablers to move towards semi-autonomous and maybe even autonomous intelligent processes. And this powerful paradigm of industrial AI overcomes the maturity hurdles of new technologies. It focuses on real-world use cases and delivers a significant measurable return on your investment on these AI-driven initiatives across the enterprise. All right, so let's talk about the future. Where are we going, and what will shape the destination and the steps along this path? So first, a glimpse: hybrid modeling. We're all familiar with traditional rigorous modeling, But we really think that if there's one example where industrial AI can bring the concept of AI to life, it's hybrid models. It leverages the best of artificial intelligence combined with domain expertise. And why is this important? Because still, a lot of you know that providing broad access to more comprehensive and more accurate models is still required and is still needed. The current technology, the traditional technology still cannot model every single phenomena that we see in the plant. However, as we move along and trying to move closer and closer to the optimum and elevate our operational excellence, understanding and predicting safely, efficiently, but more and more accurately these increased complex plants, will be essential to the design, the operations, and maintenance of the plant. You can think, for example, on in refining or in polymers, where still quite a few processes cannot be modeled with the traditional approach. But with our hybrid technology and the use of AI, we feel that that we can more accurately model more difficult processes, but also create these models faster and sustain them more easily. So that is, with hybrid models, users can model processes and assets that cannot be easily modeled with first principles alone. So you get a very high accuracy, but it is supported by the strength of first principle models. And secondly, the more comprehensive and more accurate models can be built faster. The modeling process is streamlined, is guided by AI. So it can be done by users that have less experience. And then it can be sustained longer and more easily. Hybrid models provide a better representation of the plant. It keeps the model more relevant over longer periods of time, and users can sustain those models more easily with less work and less experience. And some of the examples is, for example, polymer reactor operations is notoriously difficult to model. Gas processing, LNG, the thermodynamics, and the use of non-linear reactor models in LP, in linear programming applications. Okay, and talking about planning, another great example, I think, is cognitive guidance for planning. One of the challenges that our customers face is lack of expertise due to changing demographics and people rotating out of their roles more frequently. They have resulted, in our client base sometimes in gaps in expertise, and it takes years to gain the necessary experience to recognize, patterns in planning and scheduling and situations, and consistently always apply best practices. It's almost difficult or impractical to identify almost all the important variables, even for planners, to see everything coming. And then what I hear the most is the tremendous time that it consumes to analyze thousands of cases or 300 cases a day. So the benefits of cognitive guidance is that we can take your data that we mine for all the existing profitable plans that you've executed in the past, thousands of cases, and they can be grouped, they can be analyzed in different categories, and they can then be automated in terms of validation for the monthly operating plan to ensure you have the best possible plan without spending days and days of analysis. You can quickly locate, okay, these are winter cases, these are summer cases. In this case, we process this crude, and this happened to the plant. So we can anticipate and validate the plan on a monthly basis to enable less experienced planner to actually make these decisions and provide intelligent agents to them to assist them in these complex decision making. So I really think there's huge value in using historical models, plans, and scheduling, and put in place a process to keep them safe, categorize them, analyze them using AI, and use the outcome to guide the decision making in the planning process. So the third one is really interesting. It's a common challenge to try and diagnose the cause of process events, and it's very difficult to arrive at an answer very quickly. Investigations, I've done it myself, and I worked in the past for VP, can take weeks to plow through all the data, go through the root cause analysis, interview operations, maintenance, talk to experts, and sometimes it's very difficult to analyze these events. Using industrial AI, we can automate this, the diagnostic process, and the technology can undertake intense data processing in just a few minutes and return, to us, the analyst, accurate insights into relationships or patterns displayed in easy to understand graphs and trends. And this can enable us, the analyst, the operator, the process engineer, to get rapid understanding of the situation and take immediate action. And additionally, conditions which cause the event can be monitored online after we've done the analysis by deployment of our online agent, which can run 24/7, continually scanning for those patterns and looking for combinations of behaviors which could indicate the likely occurrence of such an event occurring again in the future. Okay. And to supplement that, another important innovation that we recently released is the technology for monitoring alerts and performance of asset performance management. We call it APM, Asset Performance Management Insights. And we think that the self-optimizing plant, in a self-optimizing enterprise plant, we can envisage hundreds of these online models, maybe thousands, of predictive maintenance agents, for example, being monitored on a huge scale that is not possible with the current technology. And this is exactly why we built this platform, that we can scale up the monitoring of thousands of these AI agents that basically keep an eye out on your plant. So many customers, they want scalable yet consistent monitoring environments. And we think APM Insights is the key because it can scale and it can extend to monitor a very broad range of online applications in your future self-optimizing plant. Additionally, because the built-in workflow capabilities that we have into the application, it can also help to automate the response. So what if an alert kicks in? What is the workflow that needs to be triggered? And this capability is all natively available in this platform. Right, and this year, actually, we introduced a new generation of cloud-enabled applications and services to power our portfolio, and we call this Aspen Cloud Services, which combines basically the best-in-class capabilities across AI and cloud to provide an enterprise architecture and an end-to-end infrastructure to connect, to collect, to analyze, and visualize asset data in the cloud. And in my earlier diagram of digital reference architecture, I call this layer the industrial AI infrastructure down at the bottom. So the benefits for our customers clearly is flexible deployment options, whether you do it private, public, or a hybrid cloud. This all can be catered to the client needs. So we don't have a one-size-fits-all approach. Our goal is to significantly improve the time to customer value from Aspen Cloud applications. And there's basically two attributes to that. One is speed. So with cloud deployment, we can accelerate value creation and value delivery at very high speeds and scale. I mean, this allows us to do massive data ingestions, processing, and storage. And we call this anytime, anywhere access. And so this enables the industrial data flow all the way from the edge all the way into the cloud in a robust and a very efficient and secure manner. And it supports enterprise-wide intelligence, visualization, and workflow. So it drives business insights, actions, and outcomes. And so these are some of the exciting, new developments that AspenTech is offering. And so you may ask, okay, Tom, so what does this all mean for the future? And I can tell you, I think the future is going to be even more VUCA. I think, history has shown us recently that don't think after the COVID pandemic, things are going to calm down and go all the way back. I think we will be living in an increasingly volatile, uncertain, complex and ambiguous environment. I don't think it's going to get any easier. So if that's the case, one of the things we see now, and somebody mentioned it earlier, sustainability is becoming more and more important going forward. Energy transition, it's really a pathway towards transformation of the global energy sector, fossil fuel-based to zero carbon by the second half of the century. And I think that is massive. And at the heart of this is the need to reduce, energy-related CO2 emissions to limit climate change. And so self-optimization, we feel, is a key step in the journey to a smart enterprise, and also a key step in how to address the future, this VUCA environment. And I strongly believe a key step in the digital journey, and here's a model of a digital journey towards sustainability, is reaching the level of smart enterprise, where human decision-making is augmented and enhanced. That's important. And where processes are aligned and automated to the next level and start becoming semi or even autonomous. And so to achieve the smart enterprise and stronger business outcomes and more sustainable operations is for your assets to become self-optimizing. And to achieve these goals, assets will have to become more self-learning. So accurately predict the future, self-adapting in real time, adjust operations based on changes in feedstocks or constraints, and self-sustaining by being able to detect anomalies and predict failures ahead of time. And so this will all be enabled by technologies that are really becoming available today. Pervasive or throughout your entire system, real-time access to data, rich domain knowledge capture and automation, and a combination of first principles with AI. Okay, in the self-optimizing plant, we believe is a key step in the journey to a smart enterprise, and the key technology enablers are industrial AI that I explained earlier, collaboration, user experience, and a cloud platform, access to data anywhere to any data from anywhere to anywhere. All right, so summarizing the value, closing the gap between planning and scheduling and operations will enable us to reduce margin leakage, which often occurs between planning and execution. With greater alignment and agility, as well as integrated optimization, we can plan more aggressively, more closer to the real optimum. And we believe our unified production optimization system is an excellent foundation for greater autonomy in the journey towards a self-optimizing plant. And with that, I think our mission is clear at AspenTech. Now with the COVID-19 pandemic, all these demand supply disruptions, entire industries is facing still strong headwinds. Price margin impacts, current crisis respond and adjusting operations to the existing climate. And then in the future, how do we prepare for a post-pandemic economy? And so we believe a business transformation is essential to meet long-term business and sustainability objectives. And we as AspenTech, we are committed to help you accelerate the digital transformation of your industries by optimizing your assets to run safer, greener, longer, and faster. And with that, I had my keynote for today on self-optimizing plant. I would like to thank you very much for your time today. And it was a pleasure for being here and giving this keynote speech to all of you. Thank you very much.